Basics of thermodynamics. In this video, let us see about system, surroundings and boundary. First, system. System means it is not a computer or laptop. In the language of thermodynamics, system is nothing but a region, a space on which we concentrate, we study all about. So according to the figure, I am giving this region, or I am treating this region to be as a system. To have a better understanding, let's imagine some examples like this. Just imagine a balloon. If we need to know more about what happens inside the balloon or what is the gases present inside the balloon means, we can take this balloon to be our system. Imagine a pressure cooker like this with a fire at bottom. If you want to know what is inside, or if you want to analyze what happens inside the pressure cooker when the food is cooked means, then pressure cooker becomes our system. Next example, imagine a compressor. One might have seen the compressor in workshops. The function of the compressor is to pressurize the fluid medium and to deliver it out. Just forget about the parts present in the compressor. Now come to this diagram. The air is absorbed inside and it got pressurized and it is delivered out. If you need to understand more about what happens inside the compressor means, then we are concentrating on compressor, then compressor becomes our system. With these three examples, we have some idea about what is system means. Let's move to the next one. Next one, boundary. Coming back to this diagram again. The outermost dark blue colored layer can be treated as boundary, but let us see with some examples. Back to the balloon again. When we treat the balloon to be a system, its outermost layer, that is maybe the plastic layer, can be treated as boundary. If you take the pressure cooker, the outermost aluminum layer can be taken as the boundary. Again, if you are taking the compressor to be as a system, then its outermost layer can be treated as boundary. Let us move to the next one, surroundings. Back to this original diagram. Whatever or whichever is out of the boundary, it can be treated as surroundings. It can be X or Y or whatever it may be. When it is out of the boundary, then it can be treated as surroundings. Now, going to the classification. A system can be classified. Let us see what is that about. First one, open system. In case of open system, energy and mass interaction happen. Just imagine a boiler. Now the boiler is system. If you are allowing the water to get inside to the boiler, and now the boiler is get filled with water. When we apply heat energy at the bottom, water will be getting evaporated, and if you have space, if you are providing space means the vapor will tend to escape out. So from this diagram we can understand that a mass of water is getting inside and mass of steam is moving outside. So mass interaction happens in the boiler, that is in this system. So mass interaction is happening. Next, energy interaction. The heat energy is getting inside to the boiler from outside. So in case of boiler, when this boiler is treated as system, here mass interaction as well as energy interaction happen. So this can be, boiler can be taken as an example for open system. Next classification, closed system. In case of closed system, mass transfer not happens, only energy interaction happens. Imagine a closed vessel filled with fluid medium or food. Okay, it is closed. We are not adding anything or we are not removing anything since it is closed. If you apply the heat energy, then we can see that no mass interaction is happening since it is closed. Only energy interaction takes place, that is heat energy is going inside the cooker. So a closed pressure cooker can be treated as a closed system. Okay, since only energy interaction happens. The next one is isolated system. In case of isolated system, there is no energy transfer and there is no mass transfer. Just imagine a thermo flask like this. If there is hot coffee or hot water and it is closed, means there cannot be any more mass transfer since it is closed, and the water or hot coffee will not spill outside since it is closed tightly. And since it is a thermo flask, no heat energy from outside will enter into it, or heat energy from inside won't go outside since it is a thermo flask. Such thermo flask can be treated as isolated system. Next, going to boundary. First classification is real boundary and imaginary boundary. Imagine a rocket, and of course you will have a nozzle and the fire which is coming out like this. If you take the nozzle to be our system, means it will be like this. So it will be like a truncated cone. It has a boundary along its sides which is real. So this can be treated as real boundary. And in case of in the top, it does not have a restriction like that in the top. Similarly in the bottom. But we can treat this to be as an imaginary layer through which the mass of hot gases can enter, and in the bottom, which is imaginary, through which the hot gases can leave. So such imaginary layer can be treated as imaginary boundary. Next part, there is fixed boundary and movable boundary. Just imagine a cylinder like this and a piston like this, which is filled with some gas or air like that. So based upon that to be a system, the outermost part, that is here the discontinuous line, can be treated as boundary. Now just imagine a pressure is applied on the cylinder. So the air or gas which is present will be getting compressed. So you can see the discontinuous line in the first diagram, which is changed in the second diagram. So when this discontinuous layer, that is discontinuous line, is treated as boundary, means here that is changed in the second diagram. Okay, what happens means the topmost boundary moves. Okay, that is, it gets moved. So that topmost layer can be treated as movable boundary, and the bottom layer or bottom boundary is fixed. It is not moving. So the top is a movable boundary and in the bottom it is fixed boundary. And there is no more classification about surroundings. And with this, viewers, I end this video. Thank you.